This is Algebra 2, Unit 6, Lesson 10 on equations of circles. Now, we talked about equations of circles last year in Common Core Geometry. We had a formula, and we used the formula to pick out the center and the radius when we worked on the problems. But where did that formula actually come from? Well, at this level, what we're going to be looking at is how to derive the formula. And it actually came from the distance formula that we learned back in Common Core Geometry. So, what we are looking at is where that formula came from for the equation of a circle. So first of all, let's try the distance. Remember the distance formula. The distance formula, the distance between 2 points x1, y1 and x2, y2 is given by d equals the difference between the x's squared, I usually call it delta x, squared, plus the difference between the y's squared, or delta y squared, and then take the square root of the whole thing, and that gives you the distance between any 2 points. Now, what do we use the distance formula for to derive the equation of a circle? Well, let's take a look. A circle, by definition, is a collection of all points that are a set distance, which is the radius, away from a point, which is its center. Okay, so if I have this point right here, that's my center point. All of the points on the circle will be the same distance away. If I pick this point over here, this point down here, any point here, any point that I draw that is on the circle will be the same distance away from the center. That's what the radius is. So the radius in the circle is 5, the center is 4, 2. So this is just some random point xy that is on the circle. Now, we are going to use the distance formula to figure out what the equation of this circle is going to be. So first of all, let's use the distance formula to show that the point 7, negative 2 must lie on the circle and verify it graphically. All right, so we want to know if the point 7, negative 2 is on the circle. I'm not going to pick it out on the graph yet. I just want to do it algebraically. Now, the distance formula says the distance between 2 points. So 7, negative 2 is my point that's on the circle, and then my center of the circle is at 4, 2. So I'm going to look at the distance between the point on the circle that we're trying to figure out and 4, 2. See if that is on the circle. Well, if we did this correctly, it should equal what the radius is. So, using the distance formula, the difference between the x's is 7 minus 4, quantity squared, plus the difference between the y's, negative 2 minus 2, quantity squared. Now, if it's on the circle, it should equal what the radius was. Well, the radius is 5. Let's see if it works. 7 minus 4 is 3 squared. Negative 2 minus 2 is negative 4 squared. And that is equal to 25. So the square root of 25 does equal 5. So that tells me that 7, negative 2 is on the circle. So if I go to 7, negative 2, 1, 2, 3, 4, 5, 6, 7, negative 2. There's my point 7, negative 2. It is on the circle. All right, so now that we know that that works for any point on the circle, let's actually derive the formula for the equation of this circle. So what we're going to do is we're going to use this random point xy. I'm going to pretend I don't know what this point is. So it's just some random point xy that's on the circle. And I have my center point 4, 2. And we're going to write the distance formula for all points on this circle. So, according to what we were just talking about, I'm going to use the distance formula. All right, so the difference between the x's would be x minus 4. Because I don't know what this x is, I'm just going to leave it as x. Minus 4, quantity squared, plus the difference between the y's. Well, it would be y minus 2, quantity squared, equals the radius, which was 5. Okay, so when I find the distance between any point in the circle and the center, that's the radius. That's what we've just figured out. Now, if I take this equation and square both sides of it, so here's my equation, x minus 4 quantity squared plus y minus 2 quantity squared equals 5, and I square both sides of the equation. What happens when you square a square root? It cancels it out. I'm left with x minus 4 quantity squared plus y minus 2 quantity squared equals 25. So that is the equation of my circle. Now, we did the equation of the circle last year. Remember, the general formula is x minus h squared plus y minus 2 squared equals 25. It's x minus h squared plus y minus k squared is the general form. Equals 25. So h and k were the center of the circle. What was the center of our circle? It was at 4, 2. So this is h, this is k. The center of the circle. And then this is the radius squared. So this should be 25, it should be r squared. Sorry about that. Getting a little ahead of myself. So this is 5 was the radius. So r squared would be the radius squared. So this is the equation of the circle. X minus 4 squared plus y minus 2 squared equals 25. So we just figured out the general equation. So now, if I know the general equation, show algebraically that the point 1, negative 2 must also lie in the circle. I can use my equation, x minus 4 squared plus y minus 2 squared equals 25. Show algebraically that this point must lie on the circle. Well, isn't this an x and this is a y? Plug them in. 1 minus 4 squared plus negative 2 minus 2 squared equals 25. Let's see if it does. 1 minus 4 is negative 3 squared. Negative 2 minus 2 is negative 4 squared is equal to 25. 9 plus 16 equals 25. So this point is on the circle because it works in the equation. So you need to know the general form of the equation of the circle because it is very, very powerful. It's a circle with centers at hk and radius at r. X minus h quantity squared plus y minus k quantity squared equals r squared. So if you know the center and the radius, you can find the equation of the circle. Let's use the equation of the circle. Which of the following equations would have a center of negative 3, 6 and a radius of 3? Well, using the formula, the center is h, k, and the radius is r. Fill in the equation. X minus negative 3 squared. So we plug in the h. Plug in the k. Y minus 6 quantity squared equals r squared would be 3 squared. All right, now let's simplify this a little bit. What is x minus minus 3? It is x plus 3. And y minus 6 is just y minus 6, and then 3 squared is 9. Now notice on here, we have x plus 3 squared plus y minus 6 squared equals 9. Notice this value right here and this value right here based on the h and k. What do you notice about the equation compared to the h and the k? They're always going to be opposite signs. So if this is plus 3, h should be minus 3. If this is minus 6 in the equation, k will be 6. And this is going to be the square. So your equation for this one should be number 2. Make sure that you square the radius as well, because notice this looks a lot like this one, or one of them, but this is not squared, so it couldn't be one of those. All right, now let's look at the equation of the circle and figure out what the center and the radius is. So we are going to determine the center of the radius, and if the radius is not an integer, it's going to be a decimal to the nearest tenth. Okay, so remember our formula, x minus h squared plus y minus k squared equals r squared. So h and k are the center, and r is the radius. Okay, x minus 2 quantity squared plus y minus 7 quantity squared equals 100. What's my center? All right, that will be my h and my k. So this is h, this is k. Following the formula, make sure, remember, it's always opposite sign. Since this is minus, it's going to be plus 2. If this is minus 7, that means it's going to be plus 7. Center's at 2, 7. And my radius, this is going to be r squared. So that means that r is going to equal the square root of 100, which is 10. Look at that. Done. All right. Center for this one. X minus h squared plus y minus k squared equals 4. My center, this is my h, this is my k. Remember, it's always opposite sign. This is going to be 5. K is going to be negative 8. And my radius, this is r squared, will equal the square root of 4, which is 2. Okay, so getting the gist of this pretty well. X squared plus y squared equals 121. All right, now how could we make this look like this? Am I taking anything away from the x on this one before I square it? No, I'm not. So what could I stick in there? Well, this could actually be rewritten as x minus 0 squared. And then the same thing for the y minus 0 squared equals 121. So this tells me x squared, if it's just x squared plus y squared, that means my center is actually going to be at the origin. My center is going to be at 0, 0. What's my radius going to be at? My radius is going to be the square root of 121, which is 11. Done. So if it's just x squared or just y squared, your coordinate is going to be 0. All right, center and radius for this one. Do a couple more here. Center. This is plus, so it's going to be minus 1. This is plus, so it's going to be minus 2. My radius is going to be the square root of 1, which is equal to 1. All right, center on this one. All right, for my h, there is no h there, so it's going to be 0. K here is going to be 3, so my center is at 0, 3. My radius is going to be the square root of 49, which is equal to 7. Done. All right, let's do one more. X plus 6 quantity squared plus y minus 5 quantity squared equals 18. Center. All right, so the h is plus 6, or 6, so it's going to be minus 6. And this is 5, so it's going to be plus 5. Negative 6, 5, opposite signs. Plus 6 becomes minus 6, negative 5 becomes positive 5. Radius is going to be the square root of 18, which is approximately, because it said to round it off, 4.2. Okay, so do we get the idea? Hope so. All right, so we'll review tomorrow on this. Why don't you do G, H, and I and see if you can figure out what the center and the radius are going to be for each one of these. Now that we know the formula, we can actually use the equation of a circle to write its equation based on just a circle, center, and 1 point on the circle. So let's take a look at these two circles. We want to write the equations for them and show how they write the answers. Remember, the general form of any circle is x minus h squared plus y minus k squared equals r squared. All right, so we have circle A and circle B. Let's do circle A. Now, for this equation, do we have h and k? Yes, we do. We have h would be 4 and k would be 1 because that's the center of the circle. All right, what we do not have is r squared. We don't know what r is. However, we can figure it out because what are 6 and 4? Well, 6 and 4 is some point on the circle, so they would be an x and a y. So let's figure out the equation for circle A using the information that we have. Following this formula, filling in what we know, x minus h would be 6 minus 4 squared. Y minus k would be 4 minus 1 squared, y minus k, equals r squared. Remember, when you have any equation or formula, and you plug in all of the variables except for one, you can solve for the missing variable. Well, we have everything except for the r squared, so we can find it. 6 minus 4 is 2 squared. 4 minus 1 is 3 squared, equals r squared. So this is going to be 4 plus 9, which is 13, is equal to r squared. So technically, r squared is equal to 13. That means the radius is going to be the square root of 13. Well, now that we know h, k, and r, we can actually write the equation. X minus, what was h? 4 squared plus y minus k, y minus 1 squared equals r squared, which is right here, is 13. That's the equation of circle A, right there. Okay, now see if you can do circle B on your own. We'll go over it in class tomorrow, and then we'll do exercise 5 as well.